increase the fonts, and also reduce this. So create your license, SPDX license. So let's do MIT, meaning that anybody can use our code. So now, once you've been able to put your license, then the next thing is to specify the version of your Solidity compiler. And how do you do that? You do pragma Solidity. Then what is the version? If you see this particular symbol, it means that the lowest should be this particular version. For example, this is our version. Means that the Solidity compiler should be lowest of 0.8.28. It can be 0.8.29, it can be 0.8.30, but if it is 0.8.27, it will not work for this particular smart contract. So it means that it starts with this, then it can go up and up ahead of that. Alright, so now that we have specified our Solidity compiler version, the next thing is supposed to then start writing our smart contract. So we do contracts, supply chain. So this is our smart contract. This is the name of the smart contract, supply chain, and this is the curly braces that mark where it starts from. This is the curly braces that mark where we are ending it. So let's start with the status of our supply chain. So let's do it now. Let's do status. So the three status that we're going to be having is created. Let's do created. Let's do picked up. It has been picked up. And let's do delivered. That's when the user have actually received it. So delivered. So now this enum is just like numeric values. So you see this as 1, you see this as 2, you see this as 3. But for your own comprehension, you should be able to read it as text. It's also seen as 1, 2, 3, but the computer or the compiler will see it as numbers. So but you will see it as text. Alright, so now let's go to struct. Struct is actually, let's see struct as structure. Let's call it struct shipment. Now this struct is just like a structure where you can define different characteristics. So when you see a structure, for example, when you see a building, you have the roof, you have the window, you have the door. So everything comes together. Sometimes you use the roof, different material. For the wall, the bricks, you use different materials. For the door, you use different materials. But everything comes together to become a building, to become a structure. So the same way in Solidity, in smart contracts, we have something called structure, where you're allowed to bring different attributes, different characteristics together to form that particular entity. So in this case, what will mark our shipment, what will mark our delivery? We are going to be having the seller, we are going to be having the logistics provider, we are going to be having the receiver, we are going to be having the price, we are going to be having when it was picked up, the distance, the delivery date, and also the status of that particular shipment. So now let's start by bringing together different entities. They might not necessarily be the same thing together to form the structure called shipment. So I'll just do address. So this is a data type in Solidity where you can specify. If you look at your Kanache, for example, this is an example, or if you see something like this, the data type of this particular entity is called address. So this is an address, this is another address, this is another address. Now, so we want to have the address of the seller. That is what we are going to be using to uniquely identify the seller. And now, take note of the fact that this will be payable because we want the seller to be able to make the payment. So when you are defining an address that will be making payments or receiving payments, you have to make them to be payable. if they are not receiving payments, if they are not sending payments, then in your smart contracts, you don't need to specify them as payable. Just put address and the unique identifier of that particular entity. So I'll just do address of the logistic provider now, because the logistic provider will also be receiving payments. I also need to mark it as payable. And from there, I will also put the address of the receiver, the person receiving the parcel. Since this person is not making payment, is not receiving payment, then I don't need to make it payable, because all you just need is the receiver to do is just to confirm they have received the parcel. Once you confirm you received the parcel, our smart contract will automatically send the payments to the logistic provider, so they are not making payments and they are not receiving payments, so we don't need to make them be payable. So also we need to set the price. So we are going to be setting the price as unsigned integer. The price. So for this entity, you can see that we have address, we have unsigned integer, all coming together to become one entity. All coming together to become one entity. So you can see the data type of this is different from the data type of this, and that's what makes a structure. Different entities, different characteristics coming together to form one structure. Alright, so now that we have the price, so every of these, see it as the attributes that make up a particular shipment. So another attribute of a shipment is the pickup date. So let's set the pickup date as string. Pickup date string, and also a delivery date. Let's set that also be string, and also the distance that the parcel will cover. Let's set that also as string, and also the status of that particular shipment, if it is created, pickup, delivery. So let's set the status to status. So now that we have that, so all these attributes, they define, you can see that we have different data types. They all define a particular shipment. So now that we have been able to do that, let us also create all these. We can call them a state variable. Don't forget we have 3 types of variable in blockchain. We have the local variable, we have the state variable, and we also have the global variable. This local variable is the one in your function. We are going to be seeing it later. And we have the state variable, which is at the smart contract level, and the global level is the one coming from the blockchain itself. So all these we can call them the state variable, because they are the contract level. Any function can call them, any function can use them. So let's define another state variable, which is the unsigned integer 256. So we set the public. Let's say shipment. We count our shipment counter. Also, so just count our shipments, and then let us also map. Let us create something we can call objects in JavaScript, where we have key value pairs. So objects, key value pairs. So let's do it as mapping. So see mapping like a key value pair. In this case, our key will be an unsigned integer. We are going to be assigning it to the shipments. We are going to be assigning to the shipments. Then that will now be public shipment. So this will be, you know that this is one particular shipment. This is the characteristics that a particular shipment we have. So now in the bit, we now map each shipment to a unique value, just like see it as the serial number, like number 1, let's say shipment for number 1, number 2. Don't forget, when I show you the front end, I was showing you some shipment IDs. So each shipment must have a unique ID that when you want to refer to that particular shipment, you should be able to refer to it as using the ID. So in this case, we are using that as mapping, where this is a unique ID and this is that particular shipment. So we are assigning to the variable called shipments in plural.